Hey guys, so welcome to level 2 of integrating and anti-differentiation. All right, so here we've got this problem. We want to integrate x plus 3 times x minus 2 dx. All right, we want to integrate it. And we want to know, what does this give us? Well, I don't know, but when we go through and do it, we're going to get y equals something. The problem is here, we've got two things that are being multiplied. Shoot, I don't know how to do it if they're being multiplied, Harper Smith. This is too hard. Don't do this too. Well, watch. It's easy. Okay? So all you do is you have to just first FOIL. That gives you x squared plus 3x. Then x times x. Let's see here. Then x times negative 2. That gives you negative 2x. 3 times negative 2 is negative 6. Those combine. What's 3x minus 2x? It's just 1x. So that leaves us with, let's see, y prime is still x squared plus x minus 6. All right, is this one going to be easy to integrate? Absolutely. Well, let's integrate it. Okay, dx, still the derivative. We integrate it, that gives us, when we add 1 to each of the exponents, it gives me x cubed, x squared, and an x plus c. Well, what would I need to multiply 3 by to get 1? 1/3. Isn't 3 times 1/3 just 1? Yeah. Got another one here. 2 times what is 1? 1/2. 2 times 1/2 is just 1. Here, what times 1 is negative 6? Negative 6. Well, Harper Smith, I thought this was going to be hard. Haha, it's not. Some of you are thinking, Harper Smith, what did you just do? Good question. I'll do another problem. All right, here's the next one. Same thing. I don't know how to solve this problem, but what I can do is I could simplify it first, couldn't I? If I simplify it first, taking the derivatives, taking the antiderivative, so integrating it isn't going to be hard. So let's start with the 4x plus 2. That's the same as saying 4x plus 2 times 4x plus 2. That's going to give me 16x squared plus 16x plus 4. Okay? Dx. I've got 3x in front still integrating. Now I can take that 3x, multiply it all the way through. That's going to give me 48x cubed plus 48x squared plus 12x. Okay? Don't forget your dx. Don't forget we're still integrating. We still don't have the answer yet. Is this simplified enough now that I can integrate? Absolutely. So y equals, I've got my x to the 4th, x cubed, x squared. 4 times what is 48? 12. 3 times what is 48? 16. 2 times what is 12? 6. Plus c, don't get the plus c. That's your answer. So if you took the derivative of this equation, you would get this equation, which then you can manipulate into being that. Okay? All right, here's the crazy one. Let's give this one a try. We've got 5x to the 8th plus 3x 6th minus 2x to the 5th all over x to the 4th. We want to integrate it. Don't forget your dx. And you're like, I just can't do that. That's too much for me, Harper Smith. I can't do that. Well, I believe you can. So let's try simplifying first. When we go and simplify, are all of these divisible by 4? Well, not divisible by 4. Could we subtract 4 from each of the x's? Absolutely. X to the 8th over x to the 4th, that'd give me x to the 4th. So that gives me 5x to the 4th. That'd give me plus 3x squared. That'd give me minus 2x dx. Hey, is that easy to do? That is super easy to do. We've got this, Harper Smith. We were just trying to pull your leg, Harper Smith. We just wanted to see if you thought it was hard. Right, okay. Well, let's integrate it. So we're going to get y equals, add 1, so that's x to the 5th, x to the 3rd, x squared, plus c. Well, 5 times what is 5? 1. All right, so just leave it like that. 3 times what is 3? 1. Okay. 2 times what is negative 2? Negative 1. Well, hey, there's your answer. That integrated very, very nicely. I like how that one turned out. All right, I want to give this one a try. What would this integrate into? Pause the video, give it a try. All right, you should have paused the video. You should have the answer by now. Here we go. So when you square it, it means that you're multiplying it by itself, the entire binomial. Okay, so this is x squared minus 6 times x squared minus 6 dx. All right, we're going to integrate that. Well, when we distribute, that gives me x to the 4th minus 6x squared minus 6x squared plus 36 dx. We're still integrating. We can combine those. That gives me x to the 4th minus 12x squared plus 36 dx. I can now finally integrate because you can't simplify that really anymore. That's about as simplified as we can get. So we add 1 to each of the exponents, x to the 5th, x cubed, x plus c. Right, 5 times what equals 1? 5 times what equals 1? 5 times 6? No. 5 times negative 5? No. What is it? 5 times what is 1? 1/5. 3 times what is negative 12? Negative 4. 1 times what is 36? 36. There you go. All right, give this one a try. Here we go. All right, pause the video. All right, you should have paused the video. Here is the answer. When we go through and do this, we've got 5x. We're going to distribute it all the way through, try to simplify this a little bit. There's a couple other ways you can do this problem. This is how I'm going to do it right now. That gives me 15x to the 5th plus 10x to the 4th. That's a big exponent. Whew. Not that 4 is a big exponent, I just wrote it big. Ha. All over x squared, that's dx. Let's see here, the 5 and the 2, the 4 and the 2. Looks like we could simplify this a little bit. We could get it to 15x cubed plus 10x squared dx. Now I can integrate, because that's about as simple as I can get it. So y equals, I've got an x to the 4th, x to the 3rd, plus c. 3 times what is 10? 4 times what is 15? Harper Smith, why do you give us problems like this? Well, when in doubt, you can always just say 4 times something equals 15. All right, well, 4 times what is 15? Divide by 4, divide by 4, x is 15 over 4. Hey, well, that's easy. If you also think about 4 times 1 over 4, they cancel out, which would give you the 15 that you needed. 3 times what is 10? Well, we'll do the same thing. 3x equals 10. Divide by 3, divide by 3. X is 10 out of 3. Okay, there you go. Now remember, the reason that we integrate, and we're not getting into it yet, but it's to find the area under the curve. So if you have a funky graph, maybe it looks like this, comes up and over like that, you want to know what's the area from the high point to the low point. If you want to know that area right there, that is calculus. You have to integrate to find that exact area. You can get close by using a left or a right approximation, but if you want to know the exact area, you have to integrate, okay? So give the assignment a try. Let me know if you have any questions.